Hello, how's it going? Here's a short video on collecting temperature with the LabJack. In order to do this, you need a LabJack unit, the U3 or T7. U3, here's the common one. And you need this amplifier unit. It's called the LabJack Inamp. And so you put positive is yellow, negative is red into one of the ports on the end here, and then you have to have for your negative 100 kilo ohm or 90 kilo ohm resistor. That's what this is, up to the ground point. The reason you have to have an amplified signal is because the voltage and the temperature change of the thermocouples are pretty small. And here is the interface with doing this with Python, measuring the temperature. You can import that U3. You can read about that online. I'll give you a link for that. That's the U3 package to be able to communicate with the LabJack. And then there's the common ones that you're familiar with math and time and date time. And then there's that D equals U3 parentheses. That's making a connection. Then I've created a function for the date time, just getting the date and the time. And it creates a tuple with the date and then the seconds from the start of the day. And then there's here some just conversions for voltage to temperature, millivolts to temperature. And here's also some more functions just for that piece. And then the get temps here, this get temperature, you can see, that's the temperature of the U3 device. It's kind of like the cold junction compensation temperature. That's what CJC stands for. That's how you need that cold junction compensation temperature to be able to get the actual temperature of the thermocouple. And you may not readily recognize that at other devices, but it does that behind the scenes always. And this dgetAIN, that's the channel. And so for the channel here, that's the 14 and 15, and you can configure that in the control panel, but that's in videos previously recorded. And so here, this get temps, it's using the voltage and then subtracts the voltage offset, this 1.249, multiplies it by 1,000 to get it in millivolts, then subtracts off the cold junction compensation millivolts, and then there's a multiplication factor that has to do with the 11 factor of the amplification, as well as the 0.04, that's millivolts per degree C typically for the range we're interested in, and then it converts that to a temperature. There's more information in terms of using Python with the U3 at this link, and I'm going to upload this sheet for you. But that link right there, you can look at LabJack low-level commands for U3 if you search that for U3. Right here, this UD example code, U3, U6, UV9. And there's quite a few examples on sending out signals, variable DAC voltage values from 0 to 5 volts. You'd use that to control your control valve. And I have a video on that. And there's other helpful commands to use. That's a familiar one, right? That getAIN, that's for a given channel. Anyway, so that's a helpful resource for you. And then back to this, like here, if I execute this code, get temps for the channel 14 and 15, it returns those two temperatures in a tuple. And then I'm simulating it. Basically, maybe I should have labeled this collect instead of sim. This is just collecting data for a given amount of time. Total time's like 5 seconds, and you're doing it 100 iterations. And you collect the data and then just sleep for a minute, and then read all that data into a dictionary. And then you can plot that dictionary. Like here, I just read 5 seconds of data and plotted it, and there's the two temperatures, for example. And then you can also do other commands. Here's one with get calibration data that returns all the calibration data for that U3 that you're using. And this graphical user interface can be helpful. I just wanted to give an example as well, but you can call within here this plot function within TKinter. I don't know if you've used TKinter, but it pulls up an executable, or not an executable, but like a graphical user interface where you can interact with code and call functions from buttons. So that can be helpful. And I'll just give you a quick example here. So I've got my thermocouple and there's some boiling water right there. So I'm gonna start this. Let me just, so I'm gonna execute that code. There's my TKinter window that comes up. And I'm gonna click the plot button and it's gonna start collecting for 5 seconds. So I'm gonna take my thermocouple and just plunge it into my hot water. And then it should show up on my plot. Maybe I was too slow, but you can see it, the time there is 5 seconds. Let's see if I can do that again. Let's run that again. So it's plotting. I put it in the hot water. Oh yeah, there we go. So you can see the water's cooled down a little bit, but it went up to almost 80 degrees there. God lives and loves us.